Assalamualaikum warahmatullahi wabarakatuh. Today we will present mini project data structure. My name Farah, Hanis BINTI AZAMAN. My metric number 25DDT21F1023 and my lecturer is Puan Nursyadillah binti Ahmad Badillah.
Assalamualaikum warahmatullahi wabarakatuh. My name is SITI RABI'AH binti JABBAR. My metric number is 25DDT21F1025. Question 1. Figure A shown a simple program for singly linked list. Based on figure A, answer all the question below. So, this is the simple program that we need to type in C++ to see the output. The first Roman question is recognize and produce an output of the code segment in figure A. So, this is the output that I get from the program, which is the list of linked lists, which is 40, 30, 20, and 10. Next, we need to draw the single linked list to insert the data referred from the program. First, insert 40, and then insert 30 next to the 40. After that, insert 20, and the last one is insert the number 10 next to the 20. So, 10 is the tail and 40 is the head. Next, based on the output from question 1 Roman, transform the output into linked list diagram based on the statement below. So, the first statement is insert number 25 between node 2 and node 3. So, 25 located between number 30 and 20. Next statement is delete node 2. Node 2 in this linked list is 30, so we need to remove node that have number 30. So, the answer after delete node 2 is 40, 25, 20, and followed by 10. Statement C is insert number 50 at first node. So, the answer is 50, 40, 25, 20, and 10. Statement D is delete the last node. So, we just remove the last node and make the number 20 as tail. And the answer is 50, 40, 25, and 20. Question 2. Using the answer from question 1 to Roman E, convert the answer from linked list to stack named XOXO with size 4 and assemble with the statement below. Okay, firstly, we need to convert from linked list to stack. Based on the linked list, we need to insert 20 first in the stack, then 25, then make the 40 at the top because 40 is the head in the linked list. Next, question A, which is they want to pop. Pop is remove data from the top of the stack. So, we need to pop out the top of the stack, which is 40, and then pop again. So, 25 need to pop out from the stack. Next, push 33. So, 33 be the top of the stack. And push 55. So, 55 be the top of the stack now. After that, push 88. So, 88 be the top of the stack. And lastly, the question wants to push 99 into the stack, but 99 cannot fit in the stack because stack is overflow. Stack overflow happen because the stack is full and not have enough space to push other data. Question 3. Circular QU is linear data structure in which operations are performed based on FIFO principle and the last position to make a circle. It is also called ring buffer. Show the step for the following circular QU implementation based on statement below and write a suitable code to perform an NQU and DQU operation. So, as we can see, this is the coding that we type in C++ to perform an NQU and DQU operation. And then, this is the output for circular QU. So, this is the answer for question 3. First, the question wants to create Q as my Q and the size is 8. In this QU, the real is -1. front is 0 and the count is 0 because there has no data. Next, the question asks to enqueue 10 in the circular queue. So, the front now is 0 and the rear is 0 after 10 inserted in the queue, and the count in the queue is 1 because there have 1 data in queue. Next, the question asks to enqueue 20 in the queue. So, 20 inserted in index 1. The front still 0 and the rear is 1 because the last data inserted in index 1, and the count of queue now is 2 because they have 2 data inserted. Next, the question 1 to DQ. So 10 DQ from the queue, so the front changed to the 1 and rear still 1. And the count in the element is 1 because 10 has been DQ, which is remove data from the queue. The last question is they want to enqueue number 30 in the circular queue. So 30 will be inserted next to 20, which is in index 2. So the rear now is moved to 2. The front is stay at 1. And the count now is 2 because of the there have 2 data in the queue now. Next, I will pass to Farah Hanis to continue the presentation.
Question 4. Based on the output above, you are required to manipulate the data in the tree based on employee information. Then traverse the tree using pre-order, in-order, post-order. There are answers for binary search tree. Need to use name as key for BST and by following alphabet A, B, C. In binary search tree, if item greater than or equal to the root, move to right subtree. If item less than root, so move to the left tree. Based on first output, the name is Amita and start with A. Second output is Haja and the name start with H. In this situation, H greater than A, so it will move to right A. Third output is Soman, the name start with S and S greater than H, so move to right Haja. Next output is Mutu, the name start with M and M less than H, so it will move to left Soman. Next output is Xiong, the name start with S. Xiong move to left Soman. It is because Soman start with FO and Xiong start with FH, but Xiong greater than Mutu, so Xiong move to right Mutu. Next output is Krishna. The name start with K less than Mutu, so it will move to left Mutu. Next output is Fasli. The name start with F and F less than H, so it will move to left Haja. Next output is Aina. It have Aina and Amita. Aina start with AI, so it's less than Amita. It will move to left Amita. And last output is Zara. The name start with Z and Z greater than S, which is Soman, so it will move to right Soman. Traverse the tree using pre-order. Pre-order start with root, then left, then right. Start with Amita, and then traverse to Aina. Traverse to Haja, traverse to Fasli, traverse to Soman, traverse to Mutu, traverse to Krishna, traverse to Xiong, traverse to Zura, and the final answer for pre-order is Amita, Aina, Haja, Fasli, Soman, Mutu, Krishna, Xiong, Zura. Traverse the tree using in order. In order start with left and the root and then the right. Start with Aina, traverse to Amita, traverse to Fasli, traverse to Haja, traverse to Krishna, traverse to Mutu, travels to Siong, travels to Somat, and the last travels to Zura. Final answer for in order is Aina, Amta, Fasli, Haja, Krishna, Mutu, Siong, Somat, and Zura. Trace the tree using post order. Post order start with the left, and then right, and then root. Start with Aina, and then travel to Fasli, travels to Krishna, travels to Siong, travels to Mutu, travels to Zura, travels to Somat, travels to Haja, and the last travel to Amita. The final answer for post order is Aina, Fasli, Krishna, Siong, Mutu, Zura, Somat, Haja, and the last one is Amita. Question 5. From the answer pre-ordered in question 4. Question A. Find Mutu using linear searching. There are answers pre-ordered in question 4. Number 1. Set the target Mutu. Number 2. Index 0. The element is Amita. Amita is not equal to Mutu. Number 3. Index 1. The element is Aina. Aina is not equal to Mutu. Number 4. Index 2. The element is Haja. Haja is not equal to Mutu. Number 5. Index 3. The element is Fasli. Fasli is not equal to Mutu. Number 6. Index 4. The element is Somat. Somat is not equal to Mutu. Number 7. Index 5. The element is the same with the target, which is Mutu. Number 8. Target found at index 5. Question 5b. Find Amita using binary searching. Based on answer question 4, the binary searching is irregular, so binary searching need to rearrange by using alphabet A, B, C. So for the first, Aina, and then Amita, Fasli, Haja, Krishna, Mutu, Siong, Somat, Zura. Step number 1. Set target is Amita. Number 2. Set first as index 0. Set last by using formula to calculate array size minus 1. So 9 minus 1 equal to 8, which is index 8. Set mid by using formula to calculate first index plus last index, divide 2. So 0 plus 8 divide 2, and the answer is 4, which is index 4. Mid is not equal with the target. Krishna is not equal with Mutu. Index number 4 until number 8 will not be searched anymore because index mid is less than index target. Number 3, target less than mid. First as index 0. Last using the formula mid minus 1. So 4 minus 1 equal to 3. So it is index 3. Mid index first plus index last. Divide 2. So 0 plus 3 divide 2 equal to 1.5. So I choose 1, which is index 1. Mid index same with the target, which is Amita equal to Amita. Number 4. Target found at index 1. That's all from us. Thank you.